Okay, let's start. So today we are going to start the electric current, resistance, and Ohm's law. Okay. Do you know what is it, electric current in the course of the physics? I think you know.
Some of this we remember.
Yeah.
Okay, if we have the like this conductor like this, so this one long wire, let's say L wire, okay, and so this side is the area. A is the cross-section area. Measured at a square. Okay. If the charge Q is going to move in this side and after that going out from this side, charge Q, it means that there is an electric current I. So electric current is equal to charge divided by time. Charge divided by time. So the unit of charge is coulomb. Okay. What about the unit of time? Seconds. Okay. So coulomb by seconds. C. Let's say S, not C. So what about the unit of the current? Unit of the current is amperes. Amperes are just big A. They are same thing. Okay. So current is physical quantity that can be measured and expressed numerically as a physical quantity. Current is the rate at which charge flows past a point on a circuit. If the quantity charge Q passing through a cross-section area of wire, the current is simple, the ratio of quantity of charge and time. It means that the current is equal to charge divided by time. Okay, as you can see here, the unit of the current, the standard metric unit for current is amps. Okay, so here you can see some example here. A 2 millimeter long cross section of wire is isolated and 20 coulombs of charge is determined to pass through it in 40 seconds. You should find here the current.
0.5.
Yes, so current is equal to charge divided by time. Here, it's not depend on the area, okay? So the I is equal to 20 coulombs divided by 40 seconds. It means 0.5 amps. What about the next one? Wire is isolated and 2 coulombs of charges determined to pass through it in 0.5 seconds. So I is 2 coulombs divided by 0.5 means 4. 2 divided by 0.5, I is equal 2 or 0.5 means 4 amps. 4 amps. So, summary, the current, if the charge is going to move in a loop, okay, if the charge is going to move in a loop, it means there is a current. Check your understanding. The current is said to exist whenever a wire is changed, the battery is present, electric charge unbalanced, electric charge move in a loop. Yes. The answer is D. What about the next one? Current has a direction. By convention, current is in the direction that positive charges move, negative electrons move, positive electrons move. The version C is
B. I don't know.
A or B. What about C?
C. It's impossible.
Yes, it's impossible because charge of electron is always negative, not positive. Okay. Current has a direction. So here in metal, if the wire is metal, like aluminum and so on, so here electrons, free electrons is moving by conductor. Okay, free electrons is moving by conductor. If the wire is metal, it means if the wire is in metal and the negative electrons is moving in this direction, so the electric current can appear there. Okay, so the answer is B. Negative charges. Okay, next one. The diagram at the right, the conducting wire to cross-sectional area are located 50 centimeters apart every 2 seconds. Then columns of charge flow through each of those areas. The current in this wire is how much? 5, yes. It's not depend on the length of the wire. Okay. Okay. Our next topic. Here there's some example also. Use the diagram at the right to complete the following statements. A current of 1 amps is a flow of change at the rate of the blah 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 coulombs per second. It means what? We have 1 amps, okay? We have 1 amps. This is the current, and it has written here every second or per second. It means the time is also 1 second, okay? You should find the charge. Charge is also 1 coulomb. Okay, B1. When a charge of 8 coulombs flows past any point along a circuit in 2 seconds, then the current is 4, yes. C1. If 5 columns of charge flow past point A, here, the point A, means that the current is going to move in this direction, okay? And everywhere the current is the same. At point A, B, C, D, and E. Everywhere the current is the same, not changed, okay? So, if the charge is equal to 5 columns and is going to move at 10 seconds, so the current is 0.5 amps. Okay, D1. In the point D here, if the current at point D is 2 amps, here is 2 amps, then how much columns of the charge flow pass in 10 seconds? Yes, 20 columns. And last one, if 12 coulombs of charge flow past point A in 3 seconds, then 8 coulombs of the charge will flow past point E in how much seconds? I have told you, so that every point the same current, okay? It means at point A, the current is equal to Q divided by T, okay? This is the point A. And the point E, also, we'll say QA, TA, and QE divided by TE. It means IA is equal to IE, okay? So QA divided by TA is equal to QE divided by TE. So we should find the TE, this one, okay? So TA multiplied by QE over QA. It means 3 multiplied by 8 divided by 12. 2 seconds. Yes. The time is 2 seconds. Understand the current. It's easy, not hard to understand, okay? So we will going to move resistance of a conductor. But the resistance depends on length and area. Okay? Okay, if we have the conductor, as I told you before, the charge is going to move in this direction, okay? This one. So in a conductor, there is a resistance. So resistance is equal to R rho multiplied by L divided by A. L is the length of the wire or conductor. A is this area, this cross-section area of conductor. A is cross-section area. Cross-section area of conductor.